Good morning, everyone. I am Julina Pinoa.
And today we're going to have another test of convergence, which is alternating series test. An alternating series test can only tell us that an alternating series itself converges. So this test says nothing about the positive term series. In other words, the test cannot tell us whether a series is absolutely convergent or conditionally convergent. Rather than it will tell us whether the series converges or diverges. So we have the general form, summation of n is equal to k to infinity of a sub n. We can rewrite that one as a sub n is equal to negative 1 raised to n of b sub n, or a sub n is equal to negative 1 raised to n plus 1 of bn, where bn is greater than or equal to 0. For all the things to be true, we know two things. So one, limit as n approaches to infinity of b sub n is equal to 0. And two, b sub n is a decreasing sequence. So for example, summation is n is equal to 1 to infinity of negative 1 raised to n plus 1 over 3n minus 2. And we can rewrite that one as summation of n is equal to 1 to infinity of negative 1 raised to n plus 1 times 1 over 3n minus 2 to get our bn. To find whether it is a decreasing sequence or not, let's just substitute the value of n to the given series. So when n is equal to 1, we have 1. When n is equal to 2, substitute the value, we get negative 1/4. When n is equal to 3, we get 1 over 7, and so on. So regardless of the sign, as you noticed, it is decreasing. So it is a decreasing sequence. So to know whether the original series really converges, let us solve its limit. So the limit as n approaches to infinity of b sub n, where b sub n is 1 over 3n minus 2. So let's get its derivative. So derivative of a constant is 0, and derivative of 3n minus 2 is simply 3. So we have 0 over 3, so it's equal to 0. So satisfying the number 1 and 2, so the original series really converges.